It takes billions of dollars, decades of meticulous planning, and massive amounts of explosive fuel just to break a piece of metal from Earth's gravity. In 1998, the United States space program launched the Mars Climate Orbiter. This $125 million machine was designed to act as a highly advanced interplanetary weather station and communications relay. Getting off the launch pad is only the first step. The probe had to travel across 416 million miles of empty space, an exhausting physical journey that took 10 full months. Finally, on September 23, 1999, the spacecraft approached its red target. The entire world watched, waiting for the mission to begin. All of those millions of dollars and months of transit came down to a single, hyper-precise orbital maneuver. To successfully enter orbit, the spacecraft had to pass exactly 140 miles above the planet's surface. Missing that narrow window leads to catastrophe. Go too high, it skips into deep space. Go too low, it burns up. Following the plan, the probe fired its engine and slipped behind Mars, cutting off radio contact. Mission Control held their breath, waiting for the signal to return, but the connection stayed dead. A state-of-the-art machine had vanished without a trace. Public forums immediately filled with conspiracies about automated alien defenses and government cover-ups to explain the sudden silence. Investigation reports revealed the true cause was an incredibly expensive middle school-level math mistake found deep in the flight logs. Building a spacecraft requires massive collaboration. NASA's Jet Propulsion Laboratory navigated the craft, while a private contractor, Lockheed Martin, built the physical thrusters and their operating software. This diagram shows the core technical conflict. NASA is a global scientific organization that uses the metric system, specifically Newton seconds, for all internal calculations. However, the team at Lockheed Martin programmed the physical thruster software using the imperial system, measuring force in pound-seconds instead. Before the rocket even launched, the mission was compromised. These two teams of brilliant scientists failed to establish a shared baseline of measurement. For 10 straight months, the ship's computer fed imperial numbers to NASA. Assuming the data was metric, NASA fed those exact numbers straight back into the navigation software. This equation reveals the danger. A single pound of force is roughly 4.45 times greater than a newton. That invisible multiplier was distorting the navigation software's understanding of the spacecraft's true location, dragging the projected safety curve further and further downward. When the thrusters fired to enter orbit, the mismatched math drove the ship completely off its intended course. Instead of passing safely at 140 miles above the planet, the probe plummeted down to just 35 miles above the surface. The probe hit the thick Martian atmosphere at terrifying speed, with the resulting friction and heat violently tearing the machine apart in seconds. The absolute smartest minds on Earth lost a multi-million-dollar creation because they forgot to double-check their unit conversions. NASA officials stood before the press to account for a profound human organizational failure. The disaster forced the agency to implement massive procedural changes, primarily the introduction of rigorous double checks on all software provided by outside contractors. NASA formally established the metric system as the absolute, non-negotiable standard across all future space projects to prevent a repeat of this incident. No matter how advanced our technology becomes, or how many millions of miles we traverse, humanity's greatest achievements remain entirely bound by our ability to clearly communicate the basics.